My name is Adam Ahringer. I'm from ABC Television, which is part of the Disney ABC Television Group. Going to go into real-time streaming solution that we did, part of our streaming show solution. Now, before I get started, I just want to provide a little context, so you know, like the information is coming, who's it coming from, so you get an idea. I'm a software development manager based out of the Seattle office. And yes, Disney does have an office in Seattle. A lot of people did not know we had a presence there. Specifically, I'm on the data platform team. Just to give you a little more context, ABC is actually part of the media networks segment of the Walt Disney Company, a giant conglomerate, right? The data platform team itself is distributed. There's myself and a few people in Seattle. Majority of the people are in Burbank at headquarters. In addition to doing software development managing, I also assist in technology architecture and build out of infrastructure. And just a little more background also on ABC Digital Media Engineering. This is a group responsible for the streaming of ABC content on a variety of platforms. I listed a few up there. The standard ones: iOS, Android, Apple TV, Roku Web, etc. On these devices, using our app, you can stream a variety of current, former shows. There's also some originals. Depending on where you're located, you can also view live stream. Some of the content is gated, and we'll get into a little bit that later. And then, of course, I wouldn't be a good Disney cast member without doing some shameless plugs, and I've listed some of our other streaming applications as well. A lot of different segments have. So please feel free to download it, watch endlessly. I'll be happy to wait if you want to download right now. All right. Just a quick agenda. I'm going to start with the challenges that we faced and some of the business drivers, some of the use cases. Also go over some of the possible solutions that we considered, and go into like which architectures we picked, why we picked them. And then at the end, I've got a few examples to share, just some nice flashy stuff. Okay, very wordy chart, slide. So some of our challenges, requirements, the business really, they want real-time analytics about user behavior. So they want to know, what are they watching? What are they doing with the application? They want it right away. We also have real-time needs from operations, but from a totally different perspective. So they want to know, how is the application performing? What are the bit rates? Are there any application errors that we know about? And there's quite a bit in there that could be useful because they can react very quickly to correct a problem if it's infrastructure related. We have also some of the more standard types of reporting, data warehousing activities. So doing reporting over a variety of dimensions, week over week, year to date, month to month, those types of things. One of the challenges we kind of imposed on ourselves is we wanted to avoid what I call data proliferation. And that's something that I've seen happen pretty often, where you start with a nice clean data set, and then maybe you make a copy, or maybe you have a slightly different version, and then before you know it, there's like 10 copies around. And people are using your data in ways you don't know, and you really have no control or even an idea of like the quality of the data they're using. So that was one of the considerations. I also wanted to point out here that on-the-shore data just was proving to not be sufficient. For a long time, that has been the standard way people instrument their applications or websites. And you do get some decent analytics from it, but they're really not timely. and they're very difficult to make changes to, and it was proving that it was just not going to be the solution for what our requirements were. So I do have this one quote here. I'll go into what I mean by that, and it has to do with, in our use case, it is pretty important that we get every event that occurs. So if someone watches a show or does a search for a particular show, that could have an effect on our picture of that user or our model of that user. And we're willing to make certain sacrifices in order to make that happen. Now, what I don't mean is that I don't expect or hope someone goes back to their office and they talk to their boss and they say, well, I went and saw this presentation by this crazy guy from ABC, and he talked about how they're just like super crazy about, every event they have to persist, and they're really willing to make all kinds of sacrifices. And he even had a slide that said, every event is sacred on it. In fact, I think it's their mission statement because he actually had quotes around it, so it must have been really important. So it's really meant to just get you thinking about like how important is each event to you? Is it okay if you miss some percentage of them? Is it going to affect the analysis that you're doing? And we'll get into a little more detail about that in a bit. Oh, okay, so it's demo time. So I love demos, and I'm going to try and do a live demo to see if it may or may not work. So as a backup, in case things go sideways, I've got a recording that's not as exciting. Okay, so here's my handy-dandy mobile phone. Oh, look, I've got all those other apps in there. That's very exciting. So I'm going to load up. The app is doing some kind of caching. Not sure what it's doing. Looks like they give me a promo, something they want to push. Designated Survivor, one of the big shows on ABC. There's also like popular. Don't ask me how they define popular. I have no idea. And there's some interesting things here. You also see they have these categories, free, drama, there's some genre-based stuff. So let's take a look at Bachelor, because you really can never get enough of the Bachelor. That and Bitcoin. So since Bitcoin is tanking, we'll concentrate on Bachelor today. So you'll see we have there's a lot of episodes of the most previous season, or the current season. Oh no, it's starting on, go back, I'm not ready. And I don't know if you can see, but some of the content has got like a little lockbox. Basically that means that's the gated content. I'll show you an example of that, but anyway, here we're doing some viewing. I just wanted to generate some activity. Oh, look, we get some commercials. That's very exciting, but since I don't really like commercials, I'm just going to get out of that. But please watch the commercials. Right? Here we go. Oh, doesn't work quite as well on the. What is going on? You'll see the little lock, right? Basically, that means it's gated. There's all kinds of crazy rules about. I couldn't get it to go. About what we can show for free. So when it's gated, it just means that you have to authenticate with your content provider, like your Dish or, oh, look, that's interesting. There's also a search. So because I love The Bachelor so much, maybe I should search for more things related to Bachelor. Or, since the title of this is Grey's Anatomy, I can say, well, it does take place in Seattle, so let's see. And so I can search and find content. And then there's help. There's help facility. And the reason why that I'm going through in painful detail here is to generate some, and then here's some feedback. Okay. Just to generate some ideas about what the different use cases are. And so depending on what your particular role is, and how do I get rid of that? Go away. What your particular use case is, you'll start thinking about what the data points are. So for example, if your field of expertise is data science, you're thinking about, oh, he did a search on a show, he watched a show, maybe he watched more than one, maybe they were the same genre, so you start thinking about, oh, is there, can I put him in a user segment, or is there some kind of clustering I can do to figure out like where these users start to cluster? From an operations standpoint, you'll see I got like a weird error there. If we can get those events to operations very quickly, they can react to those. That might be an infrastructural problem, or it might be an ad serving problem, or just some other kind of anomalous behavior. If you're a business stakeholder, you're more interested in things like engagement. How do we keep them watching, more shows without leaving? How do we get them to binge watch the whole season of The Bachelor? And how do we get them to make sure that they watch all the ads, right? All right. So let's move into what our solution. Considerations for the event production, like where the events come from. The first one here, you can see these are just examples of like where events could come from. For us, we get events primarily from mobile devices. A lot of people do use web browsers. And then I've also got a couple of little icons this one is, I think it's an EC2 instance. So you could get events coming from within your infrastructure, from server events. And the bottom one is an IoT sensor. So you could, your use case might be you're getting a flood of events from a bunch of sensors. Now for us, the events coming from mobile had a few challenges. I don't know if anyone has dealt with mobile clients, but they can provide you with headaches because of latency, right? You never know what the latency is going to be, bandwidth. How do you build in some kind of retry logic if there's messages you want to get? And you have to be cognizant of like how big is the event or the message that you're sending. For us, it was a fairly good-sized message that we're sending. And we were really interested, I mentioned this, we're really interested that we wanted to get everything that occurs. So in my little use case, I was really interested in, take special care to make sure that all those events made it into my infrastructure. So a lot of it is like, how will it impact what you're trying to do? So like if you're in a meeting and you ask your stakeholder, how many events is it okay for me to lose, right? That's like not the right thing to do because they're going to say that you can't lose anything, right? You're going to be put in a corner right away. You really have to try and figure out like what is the impact if I lose 0.01% or 1% or 10%, and figure out what you can live with. And that's kind of the way we went is there's a trade-off between performance, reliability, and some other factors with how many events we're willing to lose under certain situations. Also, not knowing what all of our future use cases were going to be, we actually instrumented the crap out of the clients. Like we instrumented things like maybe we didn't have any use cases for, but we created events for them just so that we would start collecting data. Because once you start collecting the data and you make it available, then it'll really spur a lot of innovation, a lot of ideas, and then you'll start to come up with new ways of using this data. All right, streaming system. I listed a few, the popular ones I'm sure you've heard of here, Kafka, AWS Kinesis, and then Dataflow PubSub from Google. Excuse me. Unless you guys are working at Utopian Tech Incorporated, you're going to have some kind of constraints on like what you can do. So you may go in thinking, I'm just going to pick like the best architecture, the best products, it's going to be perfect. And then you start to hear from your upper management that, oh, well, we really have to use AWS because we just signed this giant contract with them and we're going to save a lot of money or whatever, something like that. And then based on your support structure, you might also be in a situation where you're trying to go serverless whenever possible to reduce the load on your systems engineering staff. And for us, that was kind of the case. So we as a larger organization, we're trying to get off on-prem, and we're going towards everything in the cloud, and to even further, to go serverless whenever possible. So being in AWS, it really didn't leave us with a whole lot of choices. We could roll our own basically with Kafka, or use serverless with Kinesis. We ended up going with Kinesis. There's really not like a horribly wrong answer here. It really depends on your specific use case. And you're probably going to hear that a lot from me, and you're probably going to get sick of me saying it, but that's like the main thing you have to really pay attention to is what is your specific use case, and do they work for what you're trying to do? One thing I also want to note is that with all of these streaming solutions, you have to be aware of what their semantics are for deduplication. Kafka supports different semantics. They do at least once, at most once, and exactly once. It really depends on your client configuration. But depending on which way you do it, there's a cost. Okay. So there's a cost. So if you're going to configure Kafka, it's just only give you exactly one event, no matter what. There's some kind of cost that you're going to have to configure with Kafka. It doesn't come for free. Kinesis, you only get one choice. It's at least one semantics. Basically, what that means is there's a 100% chance you're going to get duplicates, and a lot of that has to do with the way it does sharding and scaling up and down. You know, it's not sure whether you received an event, so it puts multiple copies. You're guaranteed you're going to get them. So it just means that you have to be aware and decide, like, is a duplicate in your data store going to cause you a headache? Do you need to get rid of it before it's in the data store? Definitely, it's a huge part of your design. And then PubSub, I'll mention. We didn't really look at it because we're not really in Google Cloud too much. They do support at least once semantics, and they have some kind of built-in features for deduplication, but I don't really know a whole lot about some of the details. And we'll mention we did end up going with Kinesis. I think I said that, so I'll talk about more about that, how we hooked everything up. All right. Okay, so now we have events in the stream, so we need to actually consume them now to be able to use them for some kind of analytic purpose. In AWS, you actually have quite a few choices, and I just listed a few of their standard boilerplate things here. You've got like Firehose to S3 or Firehose to S3 to Redshift, and I guarantee if you walk over to these AWS guys, that's their little pre-printed architecture. They're going to say is Kinesis to S3 to Redshift, and it does like a load, and it sounds all automatic, but it does actually introduce latency, and you don't actually get access to your data in a usable way as fast as you might like. Definitely not as fast as we would like. You could also hear there's Lambda function. They very easily you can configure Lambdas to be triggered by events showing up in the stream, and then you can do a variety of things in your Lambda. It's pretty flexible. Also flexible is this little icon down here. This is what I'm calling a custom application using the Kinesis client library, the KCL. They give you integration library, and then you can basically roll your own ingestion application very easily. It's not difficult. And you can embed your own business logic. You can do any kind of special situations. You can design it to scale in the way that works for you. And for us, since it was provided like the most flexibility and really not a lot of effort to get there, that's the way that we ended up going. Also keep in mind, like, the things that you see today or the choices you have today, like by the time, if you start today and you implement in X number of months, by the time you implement this, what's on the screen is going to be different. So hindsight is not 20/20 at all, because the products that people say, why didn't you use, they might not have existed today, or they might have been a 0.2 of something where your appetite for that is just not very good. And of course, I'll repeat myself again, like, what is your use case? You have to really decide what fits best. And then the prime consideration again also is again the latency. So whatever you're using your data for, like how much can you tolerate? Is it seconds, milliseconds, a minute, a few minutes? And for us, that was one of our main drivers. Okay, so let's do a quick checkpoint here. So far, we have our mobile clients, we've got web browsers, they're remitting events to some API, which I'm purposely left off this diagram, which integrate with KPL, which is Kinesis Producer Library. Also very easy to integrate with, injects events into a Kinesis stream very easily. We're then consuming these using custom app integrated with the Kinesis client library. So now we have events that we need to persist somewhere or put somewhere that we can actually use them in some kind of analytics, anomaly detection, all this stuff that actually provides business value. So what are the considerations for our data store? And here I'm going crazy with use case, right? How are you using the data? Are you just doing like batch analytics? Or are you doing standard BI activities? Do you really want to do real-time analytics and metrics? A big consideration that's overlooked, excuse me, many times is compatibility with your tools. So your groups may already have their tool belt of things like Tableau or Looker or whatever it is, or their IDEs or their SQL tools. And if you have this really wonderful low latency system for adjusting events and you make it available in this NoSQL key value store, they're going to look at you like you're crazy because they can't use any of their tools that they're used to using, and you're going to have a problem in your hand. I'll answer your question at the end. Another consideration is the scale. How much data are you going to make available in this particular data store? And the reason why I say that is because you just have to be aware of some of the service offerings and read the details about what their limitations are. So for example, I'll just point out, Aurora, AWS Aurora has made a lot of improvements with speed and performance and things and features, and it's a nifty tool. But it does, it still maxes out at 64 terabytes, and it does scale vertically and not horizontally, so you have to just be aware of those behavior patterns of whatever you're going to put your events. Okay, so for us, we ended up choosing MemSQL. There's some more air quotes. That's the marketing thing from MemSQL. They call themselves real-time data warehousing. It's a really nifty product. I really love their tech. They're one of the players in a new field called, I guess, like translytical databases. You'll hear there's a few products using that term. Basically, it means that they can operate over very big data sets with low latency. They can handle a huge amount of inserting data, very high rate of inserts, full transactional support. And I'll mention the big, two of the big storage types of tables. Here's column store, memory store. I'm just like basically glancing over some of these features. They have a huge booth out there if you hadn't noticed, so feel free to ask them more detailed questions. But I will say, in my opinion, the column store is like where their secret sauce is. You get really, really good compression of data. And as you add more and more data, it doesn't really affect scale that you normally would see in other databases. Or, for example, if you've used relational databases, maybe they can handle very high concurrent inserts, but when you try to read the same data that you're currently inserting, you'll get locking, or there's a hotspot on the disk or something, and it's very problematic, right? Those kind of databases just weren't designed for that. MemSQL has figured out a way to get around that, and you can do analytics of data as soon as it's been committed, and there's no contention with the data that's getting inserted. Also, I mentioned tool compatibility. They utilize the MySQL wire protocol, which means you can use MySQL or MariaDB, like JDBC driver. So any tool that can use that to connect, you basically can connect to MemSQL using that interface. There are a wide variety of tools that actually natively support them to take advantage of a few extra benefits. All right. So let's take a look at the overall architecture here. So you have our architecture from before, right? We're creating them using the KPL into Kinesis. We are ingesting them using the KCL, inserting them at a very high rate into MemSQL. And you can see I've got the little dedupe marker under there. We're actually leveraging MemSQL as part of our dedupe strategy. There are things that you can do before, like I will mention, like Kinesis offers a product like, I think it's called Kinesis Analytics, which lets you do SQL-like functions on the data coming through the stream right when you're ingesting it, which is kind of cool because it's like the latency of what you're looking at is like super low, like it has just arrived. The only problem is it hasn't been deduped yet, and that may affect like some of the analytics that you want to do. It also gives you an analytical chart or whatever interface it provides in one place, and then you're going to have other analytics or dashboards, whatever, some other place. So you might be concerned with having a more cohesive, presentation of what your data is. I just thought I'd point that out. MemSQL also provides a Spark connector. It understands the way that MemSQL sharding works and how the architecture of the database works, and it really provides super enhanced performance reading data. And the reason why I've got like Spark and Parquet listed up here is that we use this paradigm to do our archiving. So for our long-term historical data, we can very easily have these really small Spark jobs that read from MemSQL right to Parquet on S3. And once we do that, then we can make it available to other of our partners within ABC. If they may have their own Hadoop cluster, or they may have some other data science groups that want access to large amount of data. And then we can just give them access to this without really having to worry about all these different stakeholders connecting directly to our database. And I also, you can see we're using Looker up there for visualizations. I don't think they're here, but they integrate natively with MemSQL. It's really easy to get up and going with Looker. We were able to get dashboards working very easily. It's a pretty nifty tool. All right, so now I've got some examples. Okay, so this is a Looker dashboard, and this is more of like an anomaly detection type of thing where you'll see like the solid shaded area will get filled in as time goes by, and then it's getting inlaid over the same pattern like week over week. So we can see like a certain pattern of whatever formula the data science guys think is important. And you can both visually, and we also have some triggers to say like, hey, based on what we're seeing, we think we're experiencing some kind of outage. And being able to see this in real time has like been super valuable. And things like this were really easy to set up. All right. Another example here, another Looker dashboard, and this is super simple, but I just wanted to show like one of the data points that we get, excuse me, from our clients is like what bit rate they're negotiating at. And we can chart that geographically, so we can do heat maps, overlaid on the United States. We can do other things, and sometimes we can even tell like, oh, there's a carrier's having a problem, because we can tell like the bit rate of certain people on a certain carrier is lower. The fact that we can get that data very quickly, we can work with these partners and try and get the issue resolved, because we're really trying to increase the user experience using our apps. All right, which is what I just mentioned. That's really what we're trying to do, right? We want to enhance the user experience with our apps. Being able to have access to this data in real time, like what the user is doing in our app, what are they watching, are they experiencing any problems, it really opens the doors to lots of things that we hadn't been able to do before. So for example, we can dynamically change navigation on the fly based on historically what they do or what things they do. We can provide recommendations, content recommendations based on what they've watched. We can apply a lot of different models. We can also issue service alerts. So my example with a bitrate problem on a particular carrier, we can maybe let them know that there's a problem and it's not their, it's not a problem of theirs, but it's something more systemic. The overall goal, like I said, is trying to improve the user experience, and all these things are possible if you have access to the data more quickly. Here is something I touched on earlier. User segmentation, right? So the data science guys love to do this. They run these simulations and models, and they self-cluster, and they want to, they figure out how to bucket these guys. For an app like this, what they really are interested in is, what kind of users do binge watching? Do they watch like the whole season at once, or under which situations do users go and catch up on what they're missing, right? So in my case, I was working on this this presentation. I didn't get to see the last 2 episodes of The Bachelor, so I'm going to go catch up, right? So I'm find out what happened to Ari. Anyway, yeah, an example. So the data science guys really like the ability to see very fresh data, very interoperable with their tools. This is just a quick example I stole from one of their dashboards. And then this example is actually interesting. We use Datadog for a lot of our monitoring of our infrastructure. And so we actually added instrumentation to our ingestion process so we get real-time metrics of our real-time metrics ingestion. In this particular dashboard, it's just showing us, as our deduplication process is going on, like how many are we finding, how many are we filtering out. And then we can use this to provide service alerts or page people, because it's important. If we see some kind of anomaly in the number of events, duplicate events we're seeing, could be some kind of systemic problem. Okay, and quick recap. I'll say it one more time, and I promise that's it. Understand your use case. I can't really stress this enough. I see like too many examples where you get this boilerplate solution from a vendor, or you see an example online and you implement it and it looks like everything's right, but it may be working as designed, but it's not meeting your use case. It's not actually doing what you need it to do. For example, it's not deduping the way you want it to. The example you're looking at, maybe they don't care about dupes because it doesn't affect their metrics. You just have to be aware of what it is you're trying to do. Keep the architecture as simple as possible. Don't overcomplicate it unless it really needs to be, because you're just creating a headache for yourself. This is probably, I don't even need to say that. Leverage your strengths. So for example, don't make your team use new tools based on some data store that's new and cool, right? Try and make everything work. Be productive using the things they're already used to. Also, don't hesitate to ask for help. Like I probably created enough, tickets and questions with MemSQL that they don't like seeing my name show up on their, on their dashboard. But that's what they're there for. So when you have a service in AWS or you license MemSQL, whatever, they're there to help you. So take advantage of the help that comes with the products you're using. And also be ready and open to pivots. You're going to get like these curveballs thrown. Try not to paint yourself in a corner, because when these things come, you're going to feel a little bit more pain versus leaving yourself an out. I think it's a good way to say. All right. That's the extent. Anyone have any questions? Oh, she's going to run around with the mic.
alerting and monitoring with Datadog. How did you integrate that? Did you have your consumers, like each consumer job, right to the API, or did you build something specific for it?
No, but they provide, Datadog actually is really good. They provide like multiple ways to get metrics into their system. We ended up using the REST API that we just put into our ingestion process itself. And basically you have to think about how you want to define the hierarchy of your metrics. If you just start emitting stuff, it's going to be hard to graph. So it was harder actually to think about how you wanted to design like the name of a metric and the hierarchy than it was to actually emit it. The emitting was just very simple. It's like, oh, this is where I want to count this up, and this is where I want to do that. And it automatically would roll up. It's just very, very easy. There's one here, and there's one back there. See, you're delving into the area which my boss likes to call "don't talk about that." So, I cannot talk about like data size, but I will say that the rate that we're ingesting into MemSQL is in the many tens of thousands per second, and it's we're having some bottlenecks in other places, but not in the database. There's one back there. There's an extra here.
Yeah, you mentioned about the Omniture data, the Adobe Omniture data is not enough, right? So you build a different path of collecting the data on top of the Omniture data?
I would say that. Wait, are you from Omniture?
No.
Okay. The Omniture is limited in what it can do. We still do use Omniture, but we instrument it in much more detail. And then one of the things we then utilize Omniture for is like it's another source of data that we can either compare or validate against.
Right. From the client perspective, when you collect the data based on the user behavior, the one which you showed, right? So basically you would be collecting like 2 times. One is for Omniture, another one is
They're collected differently. I would say that I'm not super familiar with how Omniture is instrumented. I understand there's beacons you place in various places. Right. The level of instrumentation we did is much more detailed than that. Like we get down to like very, very fine-grained things that maybe it would take a bunch of these to roll up to be the equivalent of what an Omniture event is. Like some of our events, for example, is like there was an internal error that the app got when it was calling an API from a third party, and we're able to capture the stack trace or the REST response and emit that as an event, right? Good luck trying to do that with Omniture, right? I don't know how you can get that to work. Thank you. There's behind you. I think he was been waiting.
Quick question, wondering if you're having to deal with any encryption either on the wire or at rest?
Encryption?
Either on the wire or at rest of the data?
Oh yeah, well, we know in the future we're gonna have pretty sensitive data. There's some things that we're kind of borderline, so we're encrypting everywhere. So encryption at rest, encrypting on the wire, basically from the beginning we encrypt everywhere. There was one other, oh here it is. Yeah, if I do, then I'll be posting my name on the job board here in a second.
Does all the data fit into MemSQL, or do you have some portions of the data in Parquet? And then what you would need to do is to execute one query, which is accessing both data stores?
Right now, everything goes into MemSQL because there's some, first we dedupe, right? So we've got unduplicated, but that doesn't mean like it's clean and vetted data, right? There's some metric that your business decides on like what is good data. And they may run some algorithm on it saying this data is good and now approved for consumption by other groups, right? In that case, then it's like we can use it with our tools, we put it in Parquet, and then people can read the Parquet directly.
So for how long can you keep this data in memory? Like MemSQL, you need to throw memory on this cluster every time you want to extend the retention of your data, right?
I think you're confusing the name of the product with some of the features it has. So it does have an in-memory table, the MEMS memory store, which I mentioned, but also, like I said, what is even more interesting is their columnar store, which is disk-based tables. And it's still full transactional support, and that's where you get really great compression. And since it is columnar store, when you do your queries, it only actually accesses the columns that you're picking. It's very, very fast read performance. So it scales great. Like you can keep adding history, and it does not affect performance in a linear way that you would normally expect. All right. What else? One more.
One last question. What were you using before MemSQL?
That's an interesting question. Luckily for me, it's an easy answer. This infrastructure, this product was pretty much greenfield. So we were trailing a bit in our ingestion process. So they instrumented first, knowing that they were going to use it for something. They didn't know what. So for a while, the events would come in and they were just like dumping in S3 because they didn't know what else to do with it. And then we followed up with the ingestion process. So we weren't really like replacing another database. I'm sure that's like where you're headed. All right. Thank you.